Let's practice graphing a sine function that has a reflection as one of its transformations. And if you're good with reflections and want to check out some other videos that I have dealing with some translations left and right, up and down, as well as stretching, feel free to check those out as well. For this particular video, let's focus on this function where we have f of x is equal to -2 times sine of x. Here we have our general form of our sine function, so we need to know what our a, b, c, and d values are. So if we go ahead and write those in to make this a little bit more clear, we have f of x is equal to -2. That's going to be our a value. That's going to multiply by sine of what? Well, we're going to have sine of this value of, let's see, do we have a value for b? Well, it looks like b here is just going to be 1, so it's going to be 1 multiplied by x minus the c value. Looks like c is going to be 0 here because we don't have a value. Then we go ahead and close the parentheses and the brackets, and then we're going to go ahead and add the value of d, but it doesn't look like we have anything there either, so we're going to write plus 0. Based on that, we know that our a value is going to be -2. We have our b value of 1, a c value of 0, and a d value of 0. Because b is equal to 1, we know that our period is going to stay as 2 pi. We also know there's not going to be any horizontal reflections because this is a positive value. C being 0 lets us know that we're not going to be shifting this graph left or right or translating it left or right. And because d is equal to 0, we know we're not going to be shifting this whole graph up or down any units. That being said, the main focus for this video is going to be dealing with this -2 for the coefficient of this sine function. So let's go ahead and talk about this vertical reflection, or the flip across the x-axis. Now we know that we're going to have a vertical reflection here if we have a negative a value. So because this value of -2, that is a negative number, that means we will indeed have a vertical reflection. Everything is going to flip across the x-axis. Now what about the horizontal reflection, or the flip across the y-axis? Well, in this case, we're going to have no horizontal reflection just because this is a positive number and not a negative number. If that b value was equal to a negative number, then we would have a horizontal reflection, but we don't. Now I know this video is mainly supposed to be focusing on reflections, but they're pretty straightforward, so I added in an amplitude change here as well. So the amplitude is going to be the absolute value of this a value. So if we have -2 for a, then the absolute value of that is going to be +2. So this is going to be an amplitude of 2. Moving on to the period, let's try to remember what our formula is for the period of a sine function. For the parent function, we have 2 pi as the period, but to figure it out for all other ones, we would take 2 pi and divide by b. So in the parent function, b is equal to 1, so that's why it's still 2 pi. But in this case, notice how b is still 1, so we have 2 pi divided by 1. So this isn't going to be shifting at all. This is going to stay as the same period. So it's going to take 2 pi for this whole function to repeat itself. Now for the midline, that's going to be whether we had shifted up or down at all. So if you notice here, our d value is 0. So that means our midline is going to stay along the x-axis at y equals 0, that horizontal line. Now let's go ahead and talk about our minimum y value as well as our maximum y value. The minimum y value is going to be located where we take the midline and subtract the amplitude. So our midline value is y equals 0, and we're going to go ahead and take away 2. So 0 minus 2 is going to be -2. That's going to be the minimum y value for this function. And then for the maximum y value, that's the midline plus the amplitude. So that's going to be 0 plus 2, and that's going to equal +2. So that's going to be the highest y value that this function is going to have. All right, let me just move down a little bit to get a little bit more space here. Let's go ahead and use this table for the parent function values, and then this will be after we applied our transformations for this particular function. Try to recall that for the parent function for sine waves, it always starts at the origin, goes up, and then it comes back to the x-axis, it comes down, and then it comes back up to the x-axis. So that's going to be the parent function, and it spans across from 0, and it goes all the way to 2 pi. In the middle, you're going to have 1 pi, and then you have pi over 2, and then we have 3 pi over 2, and it goes up to 1, and it goes down to -1. So if you try to remember that from the parent function, that should make your life a little bit easier here. So 0 and 2 pi for the parent function is what happens. In the middle, that's definitely going to be pi. Halfway between 0 and pi is going to be pi over 2, and then halfway between pi and 2 pi is going to be 3 pi over 2. Now again, as we go across there, it's going to start at the origin, it's going to go up to a y value of 1, back to the x-axis, down to a y value of -1, and back to the x-axis. So for sure, it's definitely really important to know what the parent function is doing, and let's see about this particular function. So remember, we said earlier that we weren't moving anything for the x values left and right at all. We also weren't reflecting anything left or right. So those are the two values that would affect it. So our period is staying the same, right? We said it's still 2 pi. So it's going to start at 0, it's going to end at 2 pi. The middle would be pi. Halfway between 0 and pi is going to be pi over 2. And then between pi and 2 pi is still 3 pi over 2. So none of the x values are going to change for this particular graph. So right away, let's just go ahead and say that we're going to start over at 0. We're going to go all the way to pi over 2, and then pi, then 3 pi over 2, and we end up at 2 pi, and that's going to complete one cycle or one period of this sine function. All right, here's where things are going to get a little bit more interesting. It's all of these y values here, right? So there's going to be no shifting from this d. This d value doesn't have any effect on it, but what kind of things do have an effect on the y value? Well, first of all, we have an amplitude that's going to multiply all the y values by 2, but we also have this reflection, right? We said yes to this because we had a negative 2. So what we're going to do is we're going to go ahead and take all of our y values that we have here, or f of x values, and we're going to multiply them by negative 2. Or you can multiply them by 2 and then write the opposite number. That's fine too, however you want to think about that. Okay, so taking this 0 over here, multiplying it by our a value, that's going to be negative 2 times 0, so that's still going to be 0. Then we're going to take this negative 2 and then multiply it by this 1. That's going to equal negative 2. Okay, so it flips it and it multiplies it by 2. Then take this negative 2 again and multiply it by 0. That's going to be back to 0. Take this negative 2 and multiply it by negative 1. That's going to be a negative times a negative is a positive 2. And then we have this negative 2 and multiply by 0 again, and that's going to be back at 0. So for this particular sine function, all of our x values stayed the same. But for our y values, we had a vertical stretch by a factor of 2 since the amplitude was 2. And we also had a vertical reflection across the x-axis since we had a negative a value. So to show this super quickly, the original or the parent function is going to go up, then down, then up, right? But the vertical stretch of times 2 means that we would go up 2 times higher, we would come down 2 times lower, and then back to 0 as well. But then the vertical reflection tells us that we're actually going to go down first, then we're going to go back up, and then come back down. So that's just a very rough sketch. That being said, you would have something along the lines of this, where we're going down times 2, up times 2, and then back to the x-axis. So this is what we're basically going to be getting shortly. Of course, we're still going to start at x equals 0, then x equals 2 pi because the period stayed the same. Pi is going to be still in the middle, and then we're also going to have pi over 2 down here, and 3 pi over 2 up here. Let's go ahead and make the more detailed graph now. So here I've labeled enough for just one period first, and I'll do the others later. So to plot this 0, 0, that's going to be at the origin, so let's go ahead and plot that first. Then we have this pi over 2 comma negative 2, so go to the right pi over 2 and then down to negative 2, plot that one below. Then we have pi comma 0, so let's go ahead and go to the right pi and stay on the x-axis. Following that, we have this 3 pi over 2 comma 2, so go to the right 3 pi over 2, then up to positive 2. Go ahead and plot a point there. And then we have this 2 pi comma 0, so go to the right 2 pi, but then stay along the x-axis. Now trying to draw a rough sketch to connect all these, let's go ahead and go down, and then let's go ahead and go through that x-axis, all the way up here to 2, and then back down to 2 pi. This would be one cycle roughly. Now to use up a little bit more of the graph, let's continue this sine wave to the right. Doing that, we can plot a point over down here next, then back to the x-axis, then back up here, and then back to the x-axis. That should look something like this when you sketch the curve. And then continuing this to our left, we are going to go plot our next point up here, back to the x-axis, down below, back to the negative x-axis, then above, then back to the x-axis, then below, and then back to the x-axis. Connecting these points in a smooth-ish curve the best we can, it would look something like this. So while this is the original one period that we graphed here, let's try to make sure we understand where it came from compared to the parent function. So the parent function, remember, would start at the origin typically, and it would go up to positive 1, through the x-axis, down to negative 1, and back to the x-axis, right? This is the parent function, but because the amplitude was 2, then it actually goes up here, and then to 2, then go down to negative 2, then back to the x-axis. And then why is it upside down? Well, because we had a negative a value instead of a positive one, then the final thing to look at here would be go down 2 to negative 2, then up to positive 2, and then back to the x-axis. Because d was equal to 0, our midline doesn't change, so it stays at y equals 0. And here you can see that our maximum y value does end up being over at positive 2 because the amplitude had an absolute value of 2. And our minimum y value here is going to be at negative 2, so our range is from negative 2 to positive 2. Last but not least, if you look at the distance between this midline and the highest value here, this goes up by a value of 2 because of that amplitude. And if we look at the distance down here, we can see this is also going to be 2 away, or it's going to be down 2, but their absolute values are still the same. So I know this video was supposed to be just mainly about reflections, but I thought it was just a little bit too easy just to flip everything upside down. So hopefully using that 2 also had an effect, and you could see what happened when we did it. So I know the main focus of this video was just trying to understand the reflections a little bit more. Hopefully throwing in that amplitude stretch as well didn't make it too much more difficult, but hopefully it helped you understand what to do if you have both transformations anyway. So hopefully you found this video helpful. If you did, please consider giving it a thumbs up and share with somebody else that might find it useful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.